So here's a sample problem that involves the addition rule. Remember that the union of events A and B, that is all the stuff inside both circles, is going to equal the probability of event A plus the probability of event B minus the intersection of those two events. So we're going to use this diagram to see if we can work that out. We know that the probability of event A is 39 because that's given to us. So 39% or 0.39. We know the probability of event B is 42 because that is given to us. So plus 0.42. Now what we don't know is the intersection, and we have to do a little bit of work to find the union. This 0.24 out here, that's telling us it's everything that's not inside of the circle, but we know our probabilities always add up to 1. So if I take 0.24 away from 1, I'm left with 0.76. And then from there, I can find the intersection pretty easily. I'm going to call the intersection x, just so I don't have to write out that entire expression right there. The intersection, probability of A intersect B, is going to be represented by x, and then I just do the math. So these two sum together to equal, let's see, 39 and 42 would be 41 and 40, so 0.81 minus x. And then if I subtract 0.81 from both sides, I am going to end up with negative 0.05, excuse me, equals negative x. Multiply both sides by negative 1, and x, or the intersection, equals 5%. So there's some algebra there, but it's pretty simple. We know this intersection piece here equals 5%. And now it should be pretty easy to find strictly A and strictly B. Because if the intersection is 5%, then that means 5% of that 39 is in the intersection, which means only 34% of it is strictly A and not in the intersection. And if I subtract 0.05, or take 5% away from 42%, that would leave me with 37%. So the probability of strictly A is 34%, the probability of strictly B is 37%, and the probability of the intersection of A and B is 5%. And if you add 34, 0.05, 0.37, and 0.24 together, you're going to get right back to 1.